welcome to our second part of multiple input, multiple output control. In this part, we will have a slightly different agenda and will dig deeper in MIMO control. At the first part, we want to remember what is a MIMO control, what is a system that is assigned to this. So you have a real life system. And this system has multiple input variables. So U1 to UI. And it has different output variables Y. Y1 to Yj, for instance. And within the system, those variables might be interacting with each other by crossing or something else, and this makes it slightly more difficult in contrast to single output, single input control. Okay, this is where we ended in the last lecture, and in this lecture we will have the following agenda. We will analyze our system more closely, and therefore we will have a look on the so-called Macmillan form of the transformation matrix. So the Macmillan form of the transfer matrix G von S. So where is this G von S? This is this is our system. So okay, that's what we want to analyze. And then we will analyze the poles and zeros of such a system. Okay, and we will compare them with poles and zeros from transfer functions. And the thing is that the poles and zeros of the transfer functions are not directly the same as within the transformation and within the transfer matrix. So that's why we have to analyze this. The next part is the state controllability and state observability. So when is such a system controllable? And observer. Okay, and well, when can we say such a system is perfectly controllable, and when is such a system observable? And yeah, what's actually meant by those descriptions? And our final part will be the MIMO control system design. So how do we actually design such a control system based on the space representation? Okay, that's what we want to do right now. For that purpose, we want to remember something that you might have learned in different lectures before. So what repetition is necessary? For my understanding, those are the poles and zeros of transfer functions. What are they and what they do they describe? Such a transfer function or transfer matrix has a complex variable S, and S is described as omega times Y. And therefore we can split such a system G von S from S in a real part and in imaginary, a complex part. yeah, of this function, and that's what is what we can do for the transfer matrix as well. And when we use those outputs, the real output and the complex output, we will have such a diagram, and our poles are then at the end yeah, and when our poles lie on the left side on this diagram, so within this, then our system is stable. Then we can call our system stable. And yeah, the poles, that's what meant by poles. And zeros, what are zeros? Zeros are from the transfer function, and they represent the linear factors of those transfer function, and they reveal some characteristics of the system directly. So yeah, and that's what we want to do in the next videos.